Check this out. We've got something really fun today. This is so amazing. Oh man, again? Let's warm up by simplifying these rational numbers. 2 over 4 can be simplified to 1 over 2, but what's happening to get 1 over 2? We're dividing the numerator and the denominator by a common factor. 2 divided by 2 is 1, 4 divided by 2 is 2. There's no more common factors other than 1, so this is simplified as low as it can go. What about the next one? If you can't see the largest common factor, that's okay. We could do it in more than one step. So if all you see in the first one is a common factor of 2, then go with that. So 56 divided by 2, 28. And 98 divided by 2 is 49. Now you can see that these both have a common factor of 7. So we'll divide top and bottom by 7, and we get 4 over 7, and that is as low as we can go. There's no more common factors other than 1. 6.1, simplifying rational expressions. A rational expression is the quotient of two polynomials. For example, a linear over a linear, a quadratic over a quadratic, or a constant over a linear. They don't have to match up. With rational expressions, we can have non-permissible values. Since that's too long to write, we're just going to call them NPVs for short. A non-permissible value is any value for the variable that will make the expression undefined. In this case, it's any value of the variable that will make the denominator 0, because then we'll be dividing by 0, and we can't do that. So for the first one, if we put 3 in here, 3 minus 3 is 0. So 3 is not allowed to happen. It would be our non-permissible value. Example 1, state the non-permissible values for each of the following. For the first one, 8x plus 16 cannot equal 0, because then we'd be trying to divide by 0. So do some algebra and solve for x. Subtract 16 on both sides. 8x cannot equal negative 16. And divide by 8 on both sides. Means x cannot equal negative 2. So our non-permissible values would be x equals negative 2. Our next one, x cubed. X cubed cannot equal 0. We could take the cubed root of both sides to cancel the cubed. Might not be necessary if you could just do some mental math. But x cannot equal 0. So our non-permissible values, if we were listing them off, would be 0. Next one is a bit strange because it's got a y in here, but we do the same thing. X minus y cannot equal 0. And add y on both sides, which means that x cannot equal y. And so that would be our non-permissible value, or value statement there. Non-permissible value, x equals y. And last one is a quadratic. And so this quadratic, the whole quadratic, cannot equal 0. So it looks like we should factor this or something to solve it. X minus 5 and x minus 5, which means it's both the same here. X minus 5 squared. Do some algebra, square root both sides, get rid of that squared. X cannot equal 5. And so our non-permissible value, we could say, is 5. When we're simplifying rational expressions, we want to factor the numerator and the denominator. Then we can tell what common factors exist. We want to state the non-permissible values before we cancel any of the information out. We want to divide the numerator and the denominator by all the common factors. And last, leave your answer in factored form. You don't want to make a mistake multiplying it back in, and probably if we go on to do more math, we'll want it in factored form anyways. Example 2a, we'll find the non-permissible value first. Looks like x is down here in the denominator, and so we cannot have x equals 0. Next, we'll look for a common factor numerator and denominator. In this case, it's 7x. So we'll divide numerator and denominator by 7x. We'll be left with negative 3 over 5x cubed. Example 2b, we've got quadratic over quadratic, so let's factor this. X plus 4 and x minus 3. In the denominator, we've got x plus 4 and 2x minus 1. Now let's list off our non-permissible values. Remember, they only come from the denominator. So x plus 4 cannot equal 0, so x cannot equal negative 4. And the other factor in the denominator, 2x minus 1, cannot equal 0, so 2x cannot equal 1, or x cannot equal 1/2. So if I was listing my non-permissible values, then I would say my non-permissible values are 1/2 and negative 4. If I just want to list them as a restriction after I've simplified, I could leave it like this and this. Let's finish simplifying this. We've got a common factor in the numerator and the denominator. It's this whole binomial, x plus 4. So let's get rid of that. This is why we had to do our non-permissible values before we canceled anything out. Because if I try to do it now, I'd be missing the negative 4 because it's gone now. Example 3. Simplify and state the non-permissible values. Let's factor first. Looks like there's a common factor in this binomial of 2. We'll factor it out, leave it in front, and we're left with x minus 3. In the denominator, I've got a 3 minus x, and that's suspiciously close to x minus 3. So if we just factor out a negative, then it's going to be negative 3 and plus x. And now these two binomials are actually the same. It's x minus 3 and x minus 3. They're just in reverse order, but they are the same thing. So before we cancel them out, let's do our non-permissible values. X, or minus 3 plus x cannot equal 0. Add 3 on both sides. X cannot equal 3. And let's simplify this. Now we can get rid of that, and we're just left with a 2 over negative. Now that's kind of weird. There's really a 1 here, we just don't write it, so it's 2 over negative 1. Never leave it like this. This is unnecessarily complicated. We've got a fraction and stuff. This can just be simplified to negative 2. 3b, let's start by factoring both quadratics here. In the numerator, I have 3x minus 2 and x minus 2. In the denominator, I have a common factor of 2x. I'll factor that out, and I'm left with 3x minus 2. Now I need to find the non-permissible values. X cannot equal 0 from the first part here, and the second part, 3x minus 2, cannot equal 0 either, and that would mean that x cannot equal 2 over 3. So there's our two non-permissible values. Now I can go on and simplify this because I have a common binomial top and bottom, and I'm left with x minus 2 in the numerator and 2x in the denominator. And I could, just for clarity's sake, put these next to it so everybody can see what they are. Example 4. Explain why the non-permissible values of a given rational expression and its simplified form are the same. They need to be the same so that the given rational expression and its simplified form are still equal. If we simplify away some of the information, then they will not be equal anymore. For example, if we had x squared over x, and we tried to simplify this to just x, these are not equal. Because this one, x, could not equal 0, and this one, x can equal 0. So we have to keep the non-permissible values the same so that when we simplify it, these expressions will be equal. Not allowed to be equal to 0 here, still not allowed to be equal to 0 here. This was part of Algebra and Number 4, Determine Equivalent Forms of Rational Expressions. So we want you to be able to simplify rational expressions, and understand the non-permissible values and how important they are.